Hey guys, we are getting ready to learn about single replacement reactions. The word replacement is really important because in a single replacement reaction, something's getting replaced. It's getting kicked out and it's getting replaced by something else. I often refer to this as the date and the third wheel. If you have ever been the third wheel on a date, you're going to know exactly what I'm talking about here. So we'll start with a little story. Let's say that Ted and Sally are getting ready to go to the movies. Everybody's excited, going to go see a new movie. They're ready to go. Well, Ted's friend calls. And Sam says, "Hey, Ted, what are you doing?" And Ted says, "Well, I'm just getting ready to go to the movies with my girlfriend." Sam says, "Wow, I sure wish I had something to do, but I'm, just kind of by myself tonight." And Ted's a nice guy. And he says, just come with us. We're just going to a movie." So they invite a friend along. Everybody's just going to the movies. So they get to the movies, everybody's having a good time, but let's say that Sam's not such a nice guy. And he decides he wants Ted's girlfriend. He's going to try to kick Ted out. And if he can do that, if he is stronger than Ted and kicks him out, now he's going to get the date. Let's put a hat on him so we can tell them apart. He's going to get the date. And Ted is going to be left all by himself. So they took the third wheel with them, and he ended up not being so nice and ended up replacing the original guy out of the date. That's what happens in single replacement. We have a compound, and then we have an element that's all by itself, like this. So let's just say that A is what we would call our third wheel and BC is the date. So this is a compound and it's going to be a metal, non-metal, and then this could be a metal or a non-metal. The third wheel can be either one, and we're actually going to look at some other exceptions as well. But in this case, let's just say that this is a metal. It will kick the metal out of the compound if it's able to do that. And if that happens, the one that got kicked out is by itself, and then A is going to hook up with C. So what you're going to have to know is what is strong enough to kick something else out. So something that I'm going to draw your attention to many times today is the activity series. We have an activity series for metals, and we have a really little activity series for nonmetals, and we just call that the activity series of halogens because these are the ones that we normally use. Now, the way you use this activity series, and you should always have one of these in front of you if you're doing any kind of problem like this. North Carolina students, this is in your reference table packet. They're real easy to use. Whatever metal is here can kick anything below it out of the way. So lithium is a third wheel you would never want to take on a date with you because lithium's going to kick you out. Okay, lithium can kick all these guys out. Calcium can kick anything below it out, but it can't kick out anything above it. So when you look at an element, anything below it, that element can kick out of a pair. Anything above it, it cannot kick out. Same thing for the real small activity series of halogens here. Fluorine is the nonmetal that you would never want to take on a date because fluorine's going to kick you out. That should make a lot of sense because we know that fluorine is also the most electronegative thing on the periodic table, meaning if you were an atom, that's like the best looking thing on the periodic table. So the activity series gives us all that information. Now, there are also some exceptions over here dealing with water and acid, and we're going to look at those in just a minute. So we're going to look at 4 different types of single replacement reactions. We're going to look at metal replacing metal. We are going to look at nonmetal replacing a nonmetal, and then we will look at a metal kicking hydrogen out of water and a metal kicking the hydrogen out of an acid. But again, if you just think about the fact that something is getting replaced, one thing is getting kicked out of the pair and replaced with something else, these are also very easy to deal with, and they are also a part of the chemical reactions in your reference table packet. You can see we're right here on single replacement. Metal replacing metal, we've got a nonmetal replacing a nonmetal, metal replacing hydrogen from water, and metal replacing hydrogen from acid. We are going to have to be real careful with the metal replacing hydrogen out of water because that one we deal with a little differently. Although they tell us exactly what to do here, it just comes back to paying attention to the details. So we'll be super careful with that one when we get to it. So we're going to start easy, and well, first of all, I want to give you an overview. So a metal replacing a metal, let me tell you what that might look like. Let's say that you have potassium with sodium bromide. Because potassium is a metal, it's going to want to kick out another metal. So it's going to want to kick sodium out. Because potassium is higher than sodium on the activity series, it can kick it out. I like to draw the little arrow showing it kind of getting booted out. And the one that gets kicked out is by itself now, and then potassium and bromine are now a pair. And I'm going to show you how to put those together when we do those examples. So that would be a metal replacing a metal. A nonmetal replacing a nonmetal would be like fluorine gas with lithium chloride. So fluorine gas is going out on a date with lithium chloride, and fluorine gas is that third wheel. Now, because fluorine gas is a nonmetal, it's going to try to kick the nonmetal out. So when it tries to kick out chlorine, it can. Chlorine's going to be left all by itself. You put a 2 on it because it is special. It's one of the 7 diatomics. And that leaves lithium and fluorine to hook up. That's a 1-to-1 ratio because lithium's a +1, fluoride's a -1. So we have a metal kicking out a metal and a nonmetal kicking out a nonmetal. So depending on what your third wheel is, that's the type of substance in these two it's going to try to kick out. And then we have a metal kicking hydrogen out of water. So let's say that we had like maybe potassium with water. And when you look at your activity series, again, I'll show you how to do this. You're going to see that yes, potassium can indeed kick the hydrogen out of water. So it's going to kick the hydrogen out. You have to put a 2 with it because it's special. And then you're also going to learn that when we look at our activity series, when a metal kicks hydrogen out of water, that metal actually crisscrosses with hydroxide. So that's going to be KOH. And then we're going to look at a metal kicking the hydrogen out of an acid. And for this one, we'll just use potassium again, and we'll use HCl for the acid. So under certain circumstances, metals can kick hydrogens out of acids. And when that happens, again, the hydrogen's left alone. You get hydrogen gas, and then the metal will hook up with the nonmetal. So these are the 4 types that we're going to be looking at. Metal replacing metal, nonmetal replacing a nonmetal, metal kicking hydrogen out of water, and metal kicking hydrogen out of an acid. So before we start, what do you need to know in order to understand this lesson? You definitely need to know where your metals and nonmetals are on the periodic table. Most people at this point know these, but just remember you have your stair-step line. Metals are on the left, nonmetals are on the right. It always is helpful to know the special 7 diatomics. Go to 7, draw a 7, add hydrogen to that party. It's helpful to know your charges. When you're crisscrossing new things together, that's going to be very important. You need to know your chemical nomenclature, how to write and name chemical compounds, specifically ionic for this. The basic parts of a chemical reaction. Reactants are on the left, products are on the right. And your guidelines for predicting the products of reactions, that is this. In your reference table packet, that's kind of like your cheat sheet, best cheat sheet you could ever imagine using. And you also need to understand how to use your activity series. So these have quite a bit of responsibility as far as what you need to know at this point in chemistry, but none of it's really hard. A couple notes I want to make about the activity series is an element, we'll just make this simple, an element can kick anything below it out. That's just kind of like how you use the activity series. It's kind of like the main rule. An element can kick anything below it out. And that's pretty much it for the activity series. I mean, it's very self-explanatory. And I'll point, for every problem, I'll point out how we're using that so you understand it. So let's go ahead and jump in. I have broken this lesson down into these 4 types of single replacement reactions so that you'll get to do lots of examples of each type before moving on. So we're going to start with reactions that show metals replacing metals. You could think about this as a cation replacing a cation, metal replacing metal. So what I'll do is I'll show you exactly what's kicking what out just to kind of help you look at the process. So basically this would be like if you had a metal plus a metal, non-metal, the metal is going to kick the metal out. And then that's going to be left alone, and these two are going to hook up. So let's look at number 1. We have zinc with copper chloride. So you ask yourself, what's the third wheel here? What's the metal by itself? And it's the zinc. So because zinc is a metal, zinc wants to kick the metal out of this. So zinc is going to attempt to kick out copper. So we have to ask ourselves, is that even possible? So we find zinc. We see that copper is below zinc. Zinc can kick out copper. All you got to do is make sure zinc's higher than copper. So now copper has just been kicked to the curb all by himself, and that leaves zinc and chlorine to hook up. Now, when you put the new pair together, go back to the original ion. So I'm going to do the scratch work right here. Zinc is a +2. Chlorine is a -1, and when those crisscross, you get ZnCl2. This 2 is here because of the way these were crisscrossed. This 2 is here because of the way these 2 were crisscrossed. But these 2's are here for 2 different reasons, if that makes sense. Number 2, aluminum's going out on a date with copper sulfate. Aluminum, the third wheel, is a metal, so I know it's going to try to kick the metal out of this compound. So we have to look at the activity series and ask ourselves, can aluminum kick out copper? So here's aluminum. Copper is below. I just saw it somewhere. There's aluminum. Ooh, there's copper way down there. So aluminum can kick copper out. Copper just got kicked to the curb all by himself, and now aluminum is going to hook up with sulfate. So let's go back to the original charges. Aluminum is a +3. Sulfate is SO4 -2. When you crisscross, you get Al2 parentheses SO4 3. So I'm going to stop right here and point some things out. A lot of students will ask me in class, why is there a 2 with this aluminum and not with this one? This 2 is here because of the way these were crisscrossed together. The subscripts come from the relationship of the 2 things that were crisscrossed. This was not crisscrossed with anything, therefore it doesn't need a subscript. There's no subscripts with the copper and the sulfate polyatomic ion because this was probably a +2 because this was copper 2, this was -2, and they canceled. So you don't want to bring baggage over. I always tell my students, for example, let's say I ask a girl, say, okay, if you get a new boyfriend, do you want him still carrying his old girlfriend's picture around with him and wearing her ring around his neck and all that? And the girl will say, no, obviously not. Well, don't carry the baggage over. You start all the relationships fresh. You're starting this relationship brand new. Let's look at number 3. We've got silver nitrate out on a date with nickel. Now, you'll notice this time the third wheel's written second. I purposefully mixed them up because it doesn't matter. As long as they're both on this side of the arrow, on the reactant side, it doesn't matter if you write this first or this first. So I wanted you to see that that's okay. So nickel is the third wheel, and nickel is a metal. Therefore, it's going to try to kick the metal out of this compound. So we look at the activity series and we ask ourselves, is nickel strong enough to kick out silver? There's nickel. Silver is below it. Silver just got kicked to the curb. And now nickel and nitrate are going to hook up. Now, in this case, we would actually have to tell you which nickel. So I'm just going to say, let's say this is nickel with a +2 charge. If we give you a transition metal all by itself, most people will tell you the charge up here and just write that down. So I'm going to say, let's treat that like it's nickel with a +2. So when nickel with a +2 crisscrosses with nitrate with a -1, that's going to give you NiNO3 2. Brand new relationship based on the charges of the two things that you just crisscrossed together. Okay, number 4, we're putting calcium with aluminum oxide. Calcium is a metal, so it's going to try to kick the metal out of this relationship. So we ask ourselves, can calcium kick out aluminum? Calcium's here. Aluminum is here. Calcium is above aluminum, so it can kick it out. Aluminum, poor thing, just got kicked to the curb. Now calcium is going to hook up with oxygen. Calcium has a +2 charge. Oxygen is a -2. Those twos cancel. CaO. Remember, and I'm showing you this each time because I want you to think about, just go back to those original individual ions and then just make that relationship brand new from scratch. All right, let's look at the next one. We have manganese 2 bromide going out on a date with lithium. Now, lithium's by itself. Lithium's a metal, so it's going to try to kick manganese out. Let's see if lithium can kick manganese out. Lithium's here. Manganese is down here. Lithium is above manganese, so it can kick it out. So manganese just got booted out. Lithium and bromine are going to now crisscross together. So you say lithium is a +1, bromine is a -1. Those ones cancel, LiBr. And the last one. We have potassium going out with iron 3 iodide. And I knew that was iron 3 because that 3 had to have come from up here. So potassium is a metal. It's going to attempt to kick out the metal in this date. So let's see if potassium is higher than iron. So there's potassium. I'm assuming it's going to be higher than iron because I definitely don't see it above it. But let's just kind of peruse on down through here. There's iron. Potassium is higher than iron. Iron just got kicked out. Plus potassium and iodide hooking up. Potassium is a +1. Iodide's a -1. Remember, go back to your original ions, and that is Ki. Now, I do want to show you why a metal is going to kick out a metal and why that's the only way it can be. And I'll use this one as an example. Let's say, so we're going to look at this again. Let's say you tried to make potassium kick out iodine. Well, first of all, the problem you're going to run into is potassium and iodine are not both on the activity series because potassium's a metal and iodine's not. Also, if you were to try to hook these up, or if you kick iodine out, let's just say you tried to kick iodine out. Well, that leaves potassium and iron to hook up. if you try to hook these guys up, you can't do it. Do you know why? What is wrong with this to where you cannot put these together? The answer is they're both positive. And remember, when Mother Nature puts atoms together, the point is to get an overall neutral charge. You can't crisscross two positives. That's not going to work. So this is why this is wrong, and that will help you remember that a metal can only kick out a non-metal. A metal can only kick out a metal. A non-metal can only kick out a non-metal, because when you put that new pair together, you have to have a positive and a negative in order to crisscross. You can't crisscross two positives and you can't crisscross two negatives, because the overall charge will not equal out to zero, or you could say be neutral, so it won't work. So these are all examples of very specifically a metal replacing a metal. And just remember, the one that gets kicked out is all by itself, and then the two that are left, you just crisscross together. Also, you'll notice when I crisscross the new pair together, we always write the positive one first and the negative one second. Positive, negative, positive, negative, because that's the way we write an ionic compound. So that is metal replacing metal. Now let's take a look at a nonmetal replacing a nonmetal. And so this would be like having a nonmetal for the third wheel and it going out on a date with a metal, nonmetal pair. But this time, since this is a nonmetal, it's going to try to kick out the nonmetal. Now we have a much smaller activity series to work with on this because we've only got 4 things on it. Fluorine's kind of king of the hill here. Fluorine can kick anything out. So this will be a little bit faster for you probably. So we have chlorine gas going out on a date with aluminum bromide. Chlorine gas is the third wheel. So since this is a nonmetal, it's going to attempt to kick out the bromine because the nonmetal will kick out the nonmetal. When I look at my list, chlorine is higher than bromine, so bromine just got kicked out. And now chlorine and aluminum are hooking up. I always write the positive one first. We know aluminum is a +3, chlorine's a -1. Remember, go back to the original ions, no subscripts. So that is AlCl3. Now I'm hoping that when you look at this, something just doesn't look right. Maybe something looks like it's missing. Do you know what it is? Okay, I feel like all of you just yelled out the right answer, so I'm going to tell you. Bromine has to have a 2. Bromine is one of the special 7 diatomic molecules. Remember, what does Beyonce say? Put a 2 on it. All right, let's look at the next one. We have bromine gas going out with sodium iodide. Bromine is a nonmetal, therefore it is going to try to kick the nonmetal out. Can bromine kick iodine out? Yes, it can. It's above iodine. Iodine just got kicked to the curb. Put a 2 on it because it's special. That's if anybody says, why do you keep putting a 2 on iodine? It's one of the special diatomics. Now that leaves sodium and bromine to hook up. Sodium has a +1. Bromine's Br -1. That is NaBr. So it's going to be I2 plus NaBr. Those are the products of this reaction. And I don't know how many of you have stopped to think about this, but guys, you are actually predicting what these chemicals do now. Before this video, you would have not been able to tell me what those do. Now you can look at that and say, if I expose sodium iodide to bromine gas, I can tell you exactly what you're going to get. You're going to get iodine gas and sodium bromide. That is pretty cool. That's a big step for a beginning chemistry student. I think that's kind of exciting. Okay, now let's look at the next one. Fluorine gas going out with sodium fluoride. Do you see anything weird about that? I purposely put this one in here. What is fluorine going to try to replace? You might be saying, fluorine, that sounds odd, doesn't it? This isn't going to do anything. So this is just kind of a bogus reaction. Up front, it might kind of look normal because you're like, well, that's fluorine gas and that's fluorine. But when you really sit and think about it, if fluorine kicks that out, you're just going to get fluorine gas and sodium fluoride again. So just be on the lookout for little tricks like that. All right, number 4. We've got iron 3 bromide and chlorine gas. Chlorine is a nonmetal. Therefore, it's going to try to kick the nonmetal out of iron 3 bromide. Let's check the list. Can that happen? Yep, chlorine can kick bromine out. Bromine just got kicked to the curb, but we're going to put a 2 on it. We're going to hook up the iron 3 and the chloride. So Fe plus 3 and Cl minus 1, that gives you FeCl3. And the last one, and at this point you hopefully have paused this and tried a few of them on your own. We've got bromine gas going out with magnesium iodide. The third wheel is a nonmetal. That means it's going to try to kick out a nonmetal. Can bromine kick out iodine? Yes, it can. Iodine just got kicked to the curb. And we're going to hook up magnesium. Remember, write the positive one first. And bromine, that's MgBr2. I also want to point out, these 2s are here for 2 different reasons. This 2 is here because iodine is special, and you put a 2 on it. This 2 is here because when you crisscross magnesium and iodine, you're going to have a 2 there as a subscript for your iodine because it came down from the magnesium having a plus 2 charge. So those are your examples of nonmetals replacing nonmetals. Now we're going to move into a few of the special exceptions. Not any harder, just follow the chart. It's going to tell you exactly what to do. So this next one we're going to look at is a metal replacing hydrogen from water. And if you look at your little cheat sheet, when you put a metal with water, the metal will kick out the hydrogen, and then the metal will crisscross with hydroxide. So we're going to write metal plus water. Then we're going to show that metal kicking out the hydrogen, so you get hydrogen gas and a metal hydroxide. So you're going to be crisscrossing that metal with hydroxide. It might be tempting to think you're going to crisscross the metal with oxygen because you're like, well, if I kick out that hydrogen, that's all that's left. But it is very important that you know you're actually crisscrossing the metal with hydroxide. So we're going to make a note about that. That is such an easy mistake to make. So crisscross the metal with hydroxide. I know that is a lot to remember, but the more practice you do, the better you will most definitely get. A lot of people are bad to get this particular one mixed up with our synthesis reaction that shows a metal oxide in water gives you a base. Do you see that subtle difference? If you have a metal oxide in water, you get a base. If you just have a metal in water, you get hydrogen gas and a metal hydroxide. So I know that can be super tricky, so just really watch out for that. It's just that paying attention to your details. So let's take a look at this one. Sodium is going out with water. Now, on the activity series, we have some special rules for water. Anything right here in this column, this little section, these guys can all kick hydrogen out of cold water. This group right here can kick hydrogen out of steam. For simplicity, we're just going to assume all of these are hot. They're steam. So if it shows that the metal can kick hydrogen out of any of these, we're going to go with it. But you would want to be careful because if someone specified, hey, it's cold water only, then it would only be this group, not all of them. So steam and cold water. Just read what you've got here, but just look out for that. We're assuming all steam for simplicity. So, sodium's in water. Is sodium in that group that can kick hydrogen out of water? So we're looking at this group here. There's sodium. It does fall in that group. So that means that sodium can kick the hydrogen out of water. So I'm going to get hydrogen gas, and then I am going to crisscross sodium with hydroxide. So I'm going to get NaOH. Sodium's a +1. I got that from sodium being a +1 and hydroxide being a -1. The ones just canceled. Number 2, potassium in water. So does potassium fall within that group that can kick hydrogen out of water? Yes, it does. It's right there. So potassium is going to kick the hydrogen out of water. You're going to get hydrogen gas. Potassium will then crisscross with hydroxide, so you get KOH. The key here again, I cannot stress this enough. I kind of feel like it deserves a little bit of a highlighter. You're crisscrossing that metal with hydroxide after you kick out the hydrogen gas. Also, it doesn't matter if I write KOH plus H2 or H2 plus KOH. The order of these two does not matter. I'm just kind of a creature of habit. Number 3, calcium in water. Can calcium kick the hydrogen out of water, assuming hot? And yes, it can, cold or hot. So, calcium's kicking that hydrogen out. So you're left with hydrogen gas and crisscrossing calcium with hydroxide, so that's CaOH2. Number 4, lithium with water. Lithium is definitely in that group that can kick hydrogen out of water. So kick out the hydrogen, that's going to give you hydrogen gas, plus we're going to crisscross the lithium with hydroxide, and that's going to give you LiOH, lithium hydroxide. And number 5, barium in water. Does barium fall in that group? It does. So barium is going to kick the hydrogen out of water. You get H2 plus crisscross barium with hydroxide. That came from Ba plus 2. OH minus 1. And remember, you could also write the reaction like this. There are so many little picky rules in chemistry. I know that some